Welcome, everyone. This is the observability talk. I can see clearly now. Hopefully, at the end of the talk, we will see clearer about application observability. This is about observing JVM applications and Spring Boot, different versions of those as well. I guess let's introduce ourselves.
All right, so I'm Tommy. This is Jonatan, and we are on the Spring team focusing on observability efforts across the portfolio. And we maintain a library called Micrometer, which is what we're going to talk about today. So, to talk about observability, we should probably start with the basics and discuss what observability is. And I think that there are a lot of definitions of observability, and a lot of people think about it in different ways and have different concrete examples of what observability is. But at a basic level, observability is how well can we understand the internals of a system based on its outputs. So the idea is you have this application running somewhere on some server. How is it doing? How are your users perceiving the system? Is it working well? Is it working fast? Are they getting errors? This is the kind of questions that you want to be able to answer with observability. So meaningful insight into what's happening inside of your applications or metadata about your applications. And so now we have an understanding of what observability is, but why do you need observability? Your application functionally works the same whether you have observability or not, right? So nowadays, applications are getting more and more complex. Microservices was heavily adopted, and so you have more and more of your applications. The interactions between your applications and dependencies are more and more complex. And nowadays, we have a new factor contributing to this, which is that AI makes it easier than ever to generate a new app, generate new code, generate new features. And so it's more important than ever that you have the ability to understand what's happening in your system.
Who is running PHP and MySQL on one single web server? No one, right? That's what we are talking about.
It's good. You should not do that. So to talk more about why we need observability, environments can be chaotic. You think that if you ship a new version to production that's when something might go wrong. But what if you don't change anything in your application? What if the data in the database changes? You have more data. An index that was working suddenly is no longer working quickly. Things get slow. And so you can't always predict when things are going to happen, so you need to be able to detect that and get to the root cause of it as quickly as possible. You have to deal with unknown unknowns. So if you knew what problems to expect up front, you could build that in. You could have a log message for when a certain exception happens. But in production, things that you didn't expect to happen. And then that's when you need observability to figure out what's going on. And things can be observed or perceived differently by different observers. So this is the classic, it works on my machine. A user tells you, hey, I tried to add this item to cart and it didn't happen. And then you go and try it and it works. Can you just say the problem's solved? No, of course not. Your user can't add an item to the cart. And so you have to be able to figure out why that's happening. You have to even know that that's happening because you're not standing right behind all of your users watching them do things, right? So this is what observability can enable for you and why it's so important that you have this. So let's go ahead and take a look at a demo.
Yeah, demo time. So we have a small demo application called T-House. It's on GitHub, open source. You can download it. It will be on the slides. You will get it. And you can play with it if you want. But the whole application is very, very simple. Or actually, this is 3 applications. The user calls a web service called T-Service. T-Service calls T-Leaf service and water services over HTTP, and they have their own databases, and those calls are going through JDBC. This is quite simple, not a lot of applications, but just enough to demo what we want. So let me show you. Go back here. This is our award-winning UI. This is the UI of T-Service. You might be able to tell that we are not UI engineers. We are working on a backend. But what it does, what is your favorite tree, Tommy? Do you like Sencha?
Yeah.
Let's sleep like a large Sencha. If you press the button, you will get like some sort of like a recipe how to make this tea. Let's say I like English breakfast. Let me get like a medium English breakfast, and if I press the button, I'm not sure I like the flavor of this tea. HTTP 500 internal server, did you break this?
I was making some changes last night with a few drinks, and I don't know what happened.
So maybe the drinks broke this. They did not like tea.
Yes, I'm blaming it on the alcohol.
Okay. So HTTP 500 internal server error. What's wrong? Like it is not a lot. Let's try to figure out what is happening. But before we go there, the description promised you a cat trying to debug a HTTP 500 internal server error. So yeah, you got this. Let's move on. So first, let's try to look into the logs, because that's most of the people. So that is something that most of the people has. So if I just like try to query some logs, not in the last 1 hour, but let's say like 5 minutes, then I see this error. Resource not found exception, resource not found TDIF with name English breakfast. Sounds familiar, but status 404 and resource not found. Why it is not 500? I saw 500 on the UI, I still see it. It's there. What is going on? So, sorry? I don't know. Like, can you tell from this? I'm not sure. So let's see. Let's dive a little bit like deeper. So first of all, let's check if this is a one-off. No, I'm pressing the button, nothing happens. Or is this broken for everyone? For this, let's look into the metrics. This is the application throughput. What you can see here, the lower graph. Ironically, the green one is the server errors, and the yellow one is success. So you can see that there is a steady stream of errors. It's not a one-off, it's not just me, it's everyone. You can check like 4.5 requests per second, around that. We have that many success outcomes, and we have server errors around 0.5 requests per second. That's kind of like 10% of the requests are failing. That's not good. We need to do something. In order to dig deeper a little bit, I would like to demonstrate you how to jump between these big signals, logging metrics, and distributed tracing. So the very first thing that we can do is jumping between logs and traces, which is like quite easy if you have some support for log correlation. Log correlation means that the trace ID and the span ID, which will basically identify these concepts in distributed tracing, will be in the logs. You can see them here. This big one is the trace ID, the smaller one is the span ID, which you can just like get the trace ID, copy paste, and you can go to your distributed tracing backend and just like look into what happened there. So I can do that, but also Grafana lets me do this just by pressing a button. So I will spare the copy paste. I'm not sure if it is faster, but maybe. And this is the tracing backend looking into the exact same request processing chain that error belonged to in the logs. So let's see what happened here. You can see that T-service get an HTTP request to the /t/name endpoint. And if I open this up, I can see some details about it. I can see the 404 in the error message. It says not found. It was a get to this endpoint, which is English breakfast, that's fine. But server error 500, something is fishy. Let's see what else do we have. You can also see that this T-service, it made an HTTP GET request, which was received by voter service. And also then made another one, another HTTP GET request, which was received by TDIF service. You can also tell, this is a timeline on the left, that these two requests, if I collapse them, they were not parallel, they were sequential. So this timeline also helps you not just like debugging latency, but also like debugging like timeliness, for the lack of the better word. So there is another interesting thing. in this distributed tracing backend. Do you see this red button? That means something is bad. That means that there was an error with that span. So you can see that as well here. TLeaf service is giving an error. So let's try to dig down and look into this. And what you can see here is that TLeaf is giving us back 404. So it seems that T-service calls TLeaf service. TLeaf service returns 404, and don't ask me who, but somebody remapped that 404 to 500. Terrible, terrible code. Don't do this. But we don't know why this is 404. Let's see what else happened here. So after this, receiving this HTTP request, you can say database connection here to the TLeaf database. So let's look into the DB connection. You can see that this is the JDBC driver of MySQL. I am using Hickory CP, and also we are connected to the TLeaf database. Okay, that's fine. What else can we learn from this? You also can see that there is a query here, or a span, and that represents executing a query. And you can see the same details here. And also, you can see that there was a select query. I'm sorry I did not write this JDBC query. This is Hibernate generated. But you can sort of tell that we are selecting a bunch of fields from the TLeaf table where the TLeaf name is something, and that something is English breakfast. So please, 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 don't ever do this in production, except if you are very, very adventurous. But theoretically, you can grab this IP, SSH to this host, use this database, and run this query, and you can see what was the result set. Instead of doing that, we have another span, an extra one here, which represents the result set. So let's look into what happened there. And oh yeah, see this? JDBC Rokan 0. That's the problem. English breakfast apparently is not in the database. So T-service called TLeaf service on HTTP, TLeaf service called the database, got an empty result set, returned 404, as it should be, and then the problem arose, and T-service got that 404, remapped to 500, and missed the resolved. So let me try to fix this error. And let's see if after putting English breakfast to the database, this is now working. This is great. Let me show you two more things, how to jump between these signals, because the only thing that we did for now to debug this is we were jumping from logs to traces. Nothing prevents you whatsoever to do the jump to the other direction, because here is the trace, you can grab the trace ID, you can go to your logs and search for that trace ID. So I teach Grafana how to do this, and there is this button logs for this span, which is kind of a lie because I am using the trace ID, so it should be logs for this trace. But if I press it, then what you can see here is a fabricated query that basically querying this trace ID. So if I go down here, I can see that there were logs from T-service, there should be logs from other services as well. If I go, yes, water service, and there should be one for, yeah, TLeaf service as well. So this is all of the logs from all of the applications that had any part in processing that HTTP request. So that's really nice. Let me show you how to jump between metrics and traces, because that could be a little bit more interesting. This was very, very easy. So the easier part between jumping metrics and traces is jumping from a trace or a span to metrics. Because if your metrics and spans, they contain the same metadata, the same keys and values, low cardinality keys and values, then actually you can grab these keys and fabricate a query in your metrics backend. So I teach Grafana how to do this. And if I click this button, then you can see that every one of these keys and its value, it was basically just copy-pasted from the span. So I fabricated a query like that, which was basically showing hey, show me all of the metric, or so show me an aggregated view for all of the spans, all of the events that happens that are similar to that. And you can see that this is basically the error rate, and it is going down to 0 because we fixed it. So that's awesome. But there is also another interesting thing here, because even if you can jump from traces to metrics, how can you jump from metrics to traces? Traces to metrics is easy. You just try to find out what is similar to this one single event. But with metrics, during aggregation, you are losing data. So how can you jump from a number, 0.5 was the error rate in this 1 minute. How can you jump from that one single number back to one of the spans that caused this? That's hard. So the answer to this is a feature called exemplars. Exemplars are metadata that you can attach next to the metrics value. And if you do that, you can actually go to your metrics. I have this dashboard here, and you can see these data points which are not connected. Those are the exemplars. Those are sample data points that contributed to that time series. So when that thing happened, a span was kind of sampled and selected that, hey, this one span is played some role for that aggregated view of that metric. So if I just go here, you should see that the trace ID is there. You can also do the copy paste, but Grafana has a button for this, query with tempo, and I can go there, which is nice. So that was basically what I wanted to demo throughout this application, and how can you basically use these signals and jump between them, and how can you use them to debug applications or get more insights from it. So let's talk about how to do this. For first with Spring Boot 2.7. Who is using Spring Boot 2? No one? Great. I tell you why.
You all passed the test.
Yes. So the easiest way to do this in 2.7 is very, very easy. Just migrate to 3.5, right? That's it. You're done. So the reason behind this, and this will be interesting if you are using Spring Boot 3 as well. Spring Boot 2.7 is out of open source support. It is not getting new updates, except if you are paying for support. So that's a problem. And 3.5 will be in the same situation in June, end of June. So this screenshot, this is from the Spring.io website. It's in the documentation or next to the documentation. So you will see the timeline of every single version. And what you can see here is 3.5 is still in green, but it is going to yellow very, very soon. You have 3 months. And after that, it will go out of open source support. So I am very, very happy that nobody is using Spring Boot 2, because this is the pixel perfect representation how I look like when I hear that somebody is using Spring Boot 2. So please don't do this to me and upgrade. Also, in 3 months, I will tell you that I will look like when I hear that somebody is using Spring Boot 3. But you are still good. If you are using Spring Boot 3.5 and you want to make it observable, it's very, very easy. Just migrate to 4. You did not see that coming, right? In that case, you will get a little dragon, because at this point, 3.5 is still supported. But yeah, it will go out of support soon.
How many people are already on Spring Boot 4? Anyone? Oh, quite a few people. That's good.
Spring Boot 3? Okay, nice, cool. So we are going to tell you anyways, how to set these things up with all of these versions.
Yeah, so thank you for that demo, Jonathan. Did that make sense to everyone? Did everyone see how you start off in the application, there was some error in the application, and then we went to go check the logs, and everyone's familiar with logs, everyone has logging in their application, but then you want to verify in the metrics, because kind of the opposite of it works on my machine is it's broken on my machine, right? Maybe it's not actually broken for every other user. So we verified in the metrics that it wasn't just our machine that it's broken on, it was broken for everyone. And then we went and looked at the tracing, and we got to find the root cause. And everything was linked together, and you can go between all of them. So is everyone using metrics in production? Who's using metrics? Okay.
That's awesome.
Who's using tracing? Okay, pretty good. So maybe you all are familiar with this, but let's go through how logging works with Spring Boot. And this talk, we're kind of trying to talk about the differences between Boot 2, 3, and 4 so that you can see the upgrade path here. But with logging, it's actually pretty simple because it's the same for all of them. So Spring Boot provides logging starters, and the default Spring Boot starter logging includes SLF4J. SLF4J is a logging facade, and logback is the implementation that implements SLF4J. So all you need to get logging in your application, add the Spring Boot starter. If you want log4j instead, you can use the log4j starter. And this is the same, again, in Boot 2, 3, and 4. But then if you want additional logging, you can add payload logs with this library called
Logbook.
Logbook, sorry. Logbook, and it has its own Spring Boot starter, and it has a Apache HTTP client integration as well. So you can log your HTTP client requests as well. And for access logs, Spring Boot has these configuration properties that you can enable. In the latest Spring Boot, Undertow is not there. That's why that's crossed out. And for GC logging, you can add JVM args to your application when you launch it. So that was logging. Let's talk about metrics in 2, 3, and 4. So for metrics, we're going to talk about a library called Micrometer. We mentioned that's the library that we maintain. And so Micrometer started off as a metrics library, and it's providing dimensional metrics. So before Micrometer, most metrics libraries that were available made hierarchical metrics, but dimensional metrics make it easier to slice down into different dimensions that you can add to your metrics. So say you want to have a dimension for the environment that a application is running in. You have your test environment versus your production environment. Or maybe you want to have a, Jonathan showed earlier, we had a status dimension, so you can see a status on what HTTP status code was returned for a metric. So Micrometer is a metrics library, think SLF4J, but for metrics instead. And it provides an API that you can use to instrument, add metrics, and you can change the metrics backend that those metrics will go to by just swapping out dependencies, and you don't have to change the actual code that you're instrumenting. And Micrometer has support for a lot of backends. How many do we support now?
This many.
This many. And you can, of course, write your own implementation if you have some proprietary metrics backend that you want to ship things to. And Micrometer is included in Spring Boot Actuator, so if you are using Spring Boot Actuator, you actually already have Micrometer on your class path and can use it. And all of the Spring projects are instrumented using Micrometer, so that's how you get all of those metrics out of the box. So Jonathan did that demo, and remember the code is available online. But if you look at the code, you might be kind of shocked at how little code there is related to observability itself, because a lot of the observability is provided out of the box because the instrumentation is in the projects themselves.
What I showed you, zero code.
Yeah. So Spring projects are instrumented with Micrometer. Even other projects that are not in the Spring portfolio also are instrumented with Micrometer. These are the supported backends and protocols. And I mentioned the actuator starter. So if you have actuator, you get metrics. And you can add a specific backend. So in this case, the Prometheus registry. And if you wanted to ship metrics to a different backend, you would add just Micrometer registry and the name of the backend. Supported, we ship metrics there. And you can even add multiple meter registry implementations and have metrics for both or multiple backends.
And I guess it is not on the slide, but this works like the previous slide. It works for Spring Boot 2, 3, and 4.
Yeah.
So you can do that, no change.
Yeah, so with Spring Boot 4, if you're familiar, there was a big modularization effort, and so some of the starters and options changed, but the actuator starter is still there even in Spring Boot 4, but you have this new option, Spring Boot Starter Micrometer Metrics. So you can add Micrometer via a starter without necessarily adding the actuator if you don't want the actuator in your application. And then the same as before, you add the registry implementation that you want. All right, that was metrics with Spring Boot, and I'll hand it off to Jonatan for tracing.
So let's talk about what you can do if you want to add like distributed tracing to your application, whether you are using Spring Boot 2, 3, or 4. With 2.7, like I will be quick because no one is using it anymore. But the distributed tracing support was through a library called Spring Cloud Sleuth. And Spring Cloud Sleuth basically provided an abstraction layer over tracing libraries. And 2 of them were supported. One of them is called Brave from the OpenZipkin community. The other one is called OpenTelemetry. That's a CNCF project. And Brave was kind of like the default because it is more like mature project. OpenTelemetry is a little bit like younger and more experimental. There are still parts of OpenTelemetry that are not stable yet, but these are in heavily codes because there is no default. You need to you need to choose one. You need to tell like which one do you want. So yeah, a lot of Spring applications, like Spring projects, were like instrumented with Sleuth, and also like Sleuth supports various backends because these 2 tracing libraries also supports various backends. Sleuth needs these tracing libraries to operate. So what you need to do if you have like 3.5? Let me jump between these 2 slides. Can you spot the difference? Not much. What happened in this Spring Boot 3.0 timeline when we released 3.0? We also released a project called Micrometer Tracing. So Micrometer Tracing was born by copying the code base of Sleuth and putting it under the Micrometer umbrella without the Spring parts. Spring Cloud Sleuth, it has dependencies on Spring Cloud and Spring Boot. Micrometer Tracing does not. You can use Micrometer Tracing with any JVM application. You don't need to use Spring if you don't want to. Other than that, and we renamed the package, it's the same. If you are familiar with the Sleuth API, the Micrometer Tracing API looks exactly like that. If you want to use Brave, that tracing library with Micrometer Tracing, then these 3 dependencies what you need. Actuator, you need to choose the bridge Brave, which will give you like the support for the Brave tracing library. And then you need to tell Brave where to report the data. And this is, I'm just using a Zipkin reporter here, and that's it. If you omit that last one, you will still get the trace ID and the span ID in your logs, but the data will not be sent to anywhere. The spans will not be reported to a backend. If you want to use OpenTelemetry, let me jump between the slides again. You can spot the difference. It's not a lot. See the second line? You just change the name from Brave to OTel, and that's it. And then you need to tell OTel which exporter you want to use, and this is the OTLP exporter. So this was the Spring Boot 3.5 way. You needed these 3 dependencies. And a lot of people thought this is too much. So Spring Boot 4, we have a Zipkin starter, and we have the OpenTelemetry starter, which is doing exactly like that, what you saw in the previous 2 slides. They are adding these dependencies and the auto configuration for that, except since this is a OpenTelemetry starter, and OpenTelemetry also supports metrics, the OpenTelemetry starter will bring in the metrics support of Micrometer. If you don't want it, you have 2 options. 1, exclude that. 2, don't use the starter, but do those 3 dependencies, and that's it. So yeah, with Boot 4, you can just have one starter for these. For OpenTelemetry logging, for OpenTelemetry logging, we don't really have a starter or very, very exhaustive auto configuration, because the logging support for JVM applications in OpenTelemetry is not stable yet. Once it will stabilize, we can add more and more bits. There are also new modules. So you can see there is Spring Boot Micrometer Tracing Brave and Micrometer Tracing OpenTelemetry. You can use this as well. If you want, we highly, highly recommend to use the starter instead, but these are the modules that will be used under the hood. You still need a tracing library, like a bridge, and also a reporter or an exporter. So you will not get away using those. If you want to learn a little bit more about OpenTelemetry and Spring Boot 4, then there is a very, very nice blog post, OpenTelemetry with Spring Boot. It's on the Spring.io blog, written by our colleague Moritz. Also, if you want just, basically, you don't want to memorize these dependencies because you are not Josh Long, then you can just go to start.spring.io and start typing OpenTelemetry or Zipkin or whatever. And if you choose the Spring version, like the Spring Boot version, 3.5 or 4.0, it will give you the right dependencies for that version. So if you are just typing OpenTelemetry, in case of 4, you will get the OpenTelemetry starter. If you use 3.5, you will get those 3 dependencies that I showed you. I talked about logging. So logging support is, there are some bits there, but it is not complete because those append their support for JVM application for logback and log4j in OpenTelemetry, they are not stable. Also, read the docs, please. I'm not sure if you are aware, but all of the Spring Boot documentation, they are versioned. So you can see like, hey, what should I do with 3.5 or what should I do with like 4.0? And also, there is a boot 4.0 migration guide, which, by the way, it also exists like boot, so for boot 3.0, but since you are not using boot 2, that doesn't matter for you. That guide is golden. Please, if you want to migrate to, you want to migrate to Spring Boot 4. So when that happens, please read that guide. That contains very, very vital information for you and like migrating the project. So let's talk about the observation API, which is a very, very nice like thing in Micrometer, if you ask me.
Right. So we talked about logging and metrics and tracing. So what's this observation API thing? We kind of realized that typical flow that you go through when you want to instrument your application, you have some operation that you want to time, and so you add some logs, maybe a start and an end log, or you log how long the thing took. Maybe you add some metrics around how long that takes. You add some tracing so that you can get to the root cause, figure out the cause of latency. But now you're having to add logs and metrics and tracing, and so you're doing kind of not the same thing 3 times, but you're having to repeat this process of instrumenting your application. We thought, wouldn't it be nice if there was just one API that you could use to instrument your application and get all of these things out of it? So that's kind of how the observation API came about. We added this in Micrometer 1.10, boot 3.0, and this is in the Micrometer observation module. Micrometer core has a dependency on it, so if you're using Micrometer core, you already have this on the class path. And so as I explained, it's this higher level abstraction over metrics and tracing for timing an operation. So think about if you want to time how long an HTTP request takes to process on a server. That's something that you could have in metrics a timer for, or in tracing you could have a span for that. But now we have this higher level abstraction, the observation API. You can have an observation for that. So the idea is to instrument it once with the observation API, and then you can add handlers to the observation API configuration, and that will add anything that you want. So we provide out-of-the-box handlers for metrics and tracing, but you could add it for logging and any other purpose that makes sense for you. So the demo app that we showed, I said the instrumentation is provided by the project, so you won't really see a lot of observation or observability code in there. All of that instrumentation is done using this observation API. So what does it look like? Here's some code for using the observation API. So observation.start, you pass an observation name, and you pass an observation registry, very similar to a meter registry if you're familiar with the metrics API. And then you, after starting it, you do the thing that you're trying to time, and then eventually you call observation.stop. And if an exception happens, you can tell the observation that this error happened. So that looks pretty similar to what you would use if you were using a timer or if you're using a tracing API. And that's intentional because we had in mind that we want to be able to get metrics and tracing out of this. But if you just write this previous code and you don't register any handlers, doesn't do anything. You're starting and stopping and nothing really comes out of it. So it's really these handlers that you register that cause anything to happen. And so, as I mentioned, we have metrics, we have handlers that we provide for metrics and tracing, and you can create other handlers that do other things that you want. So when the start method is called and the stop method is called, or when the error is attached, you can have these handlers react to those events happening and do something. The metrics handler is just starting a timer on start, ending a timer on stop. Same with tracing, starting a span on start, ending a span on stop. So the observation handlers, Spring Boot has auto-configuration for this. And so if you have the right things on your class path, it will just auto-configure the metrics handler, the tracing handler. You don't have to do that. But if you wanted to provide your own custom handler, you can just register that as a bean, as you typically do in a Spring Boot application, and Spring Boot will auto-configure registering that handler to your observation registry. So some other API that we didn't show before. Observation has the concept of low cardinality key values and high cardinality key values. So in metrics, this corresponds to tags. Metrics, hopefully you know, should not be using high cardinality tags. So that's why we have this separation here, so the observation handlers can decide whether they want to use the low cardinality key values or the high cardinality key values. So the default tracing handler will use both the low and the high cardinality key values. The metrics will only use the low cardinality key values. And I guess to explain that a little bit in case anyone's not familiar, low cardinality means that you have a bounded number of items that could be included. High cardinality is something that has unbounded number. So something like a user ID or a unique ID or something that you're accepting, some value you're accepting from user input is inherently high cardinality because users could provide anything. So you want to make sure that you're not using that in the low cardinality because that'll get added to your metrics and cause a huge memory issue, performance issue in production for you. You don't want that. And there's also this observe method on the observation. So this is a shortcut, so you don't have to call those start and stop. You just pass it a method reference, and then we'll take care of calling start, stop, and catching any exception and marking that as an error on the observation. And then if you don't want to do things programmatically, similar to how we have a @timed annotation or @new span annotation, we have annotations for the observation API as well. So we have an @observed and @observation key value, so you can use aspect-oriented programming to achieve the same thing. And I guess we have a little bit more time. Do you want to show them what's new?
Yes, let's go there.
So you guys get a little extra hidden slides here. We actually do a slideshow from hidden slides.
Oh, it works. Cool.
All right. So Jonathan demoed exemplars. Who thought that was pretty cool? Is anyone using exemplars in production? Exemplars? Anyone? Thomas, of course, we know.
OTLP or Prometheus? Both?
So in the demo, we showed Prometheus for the metrics backend. We are adding support for exemplars to the OTLP meter registry. And that's coming up in boot 4.1, Micrometer 1.17. So that'll be something new.
Yeah, basically next month.
Yeah, so I just showed the observation key value annotation. That is relatively new, analogous to the @meter tag if you're using the @timed annotation. We added an OTLP metrics sender abstraction. So previously we provided an implementation of how OTLP metrics were sent from the OTLP meter registry to the backend. And now we've just made an abstraction so that you could provide your own OTLP metrics sender if you want to use a different HTTP client. Or if you don't even want to use HTTP at all, you could use gRPC. Allows you that flexibility to implement it how you want. We added some additional metrics for virtual threads, Jakarta mail instrumentation, JSpecify. Who's familiar with JSpecify? Okay, so this was kind of a portfolio-wide effort in the Spring portfolio, adding nullability annotation support. So now Micrometer has JSpecify nullability annotations throughout the code. This means that you know what is returning null and what accepts null or does not.
This is very important. If you have never heard about it, or if you are not using, please look into JSpecify and nullaway, which is like a compiler plugin with error prone, so that the compiler will yell at you if you are doing something bad around like nullability, instead of users are yelling onto you because they are seeing a null pointer exception in production.
And then we added a meter convention. So we previously had a thing called observation convention. So the idea is that if you're writing instrumentation, and particularly if you're a library writing instrumentation, you want to allow your users the option to customize the semantic convention that's used. So you might come up with a name, but so if it's, say, JVM memory metrics, it might be JVM.memory.max to get the maximum memory that's configured on the JVM. But maybe in your organization, you have some predefined convention that says that that shouldn't be called JVM.memory.max. It should be called Java.memory.max. And so you want to be able to change this, but you don't want to have to rewrite the whole instrumentation yourself. So this convention concept here is a way to make that more flexible so that a instrumentation can be written and users can provide their own convention, or we can have default implementations of conventions that match something. So OpenTelemetry defines its own semantic conventions, and this meter convention and observation convention are the way in Micrometer in which you can swap out the convention. And so you could make an implementation of meter convention or observation convention that matches the OpenTelemetry semantic convention. So this is useful if you have dashboards that are built expecting a certain naming convention for what things are supposed to be called, then especially if you're working in a system that uses different languages, and so maybe you have applications that are written in Python or in Node.js, and those are obviously not going to be instrumented with Micrometer because it's a Java library, but they're going to have their own metrics, and it would be nice if applications written in different languages all called the same metric the same thing, or the same span the same thing. And so this is what the semantic convention effort is for, and we've added meter convention and observation convention. And so those are there. We're working on making it more easy to auto-configure, say, you want all of the instrumentation to use the OpenTelemetry semantic conventions that are mark stable. It's currently possible to do that, but it takes a little bit of manual configuration. The blog post that Jonathan shared earlier about OpenTelemetry in Spring explains this. We're working on making that easier so that maybe it will be just one configuration option to say, give me change all of the semantic conventions for all of the different instrumentation to match OpenTelemetry.
One more thing with the OTel semantic conventions, if you want to use them, a lot of them are not stable yet, which means that it will change possibly in the future. So that can break you, that can break your dashboards, and that can break a bunch of things. We only use or provide OTel semantic, these open observation conventions for OTel semantic conventions that are stable. Namely, the JVM conventions, they are stable, and also we have conventions for HTTP clients. Other than that, as they stabilize, we are planning to add support for them gradually.
Yep, and then in the most recent release, we used to have an issue because the Prometheus Java client does not allow you to make metrics that have the same name but a different set of tags. So say you might have a HTTP server request metric, and when there's no exception, you want to not include an exception tag at all. But then when there is an exception, you want to include the exception tag with the name of the exception that was thrown. That doesn't work in Prometheus because it expects, hey, I saw an exception tag, you should always have an exception tag on the same metric. So that was a restriction that is now going to be lifted in the upcoming Micrometer 1.17 because the underlying Prometheus Java client removed that restriction. So just a little bit of a difference between Prometheus and other backends. Talk about.
Yeah. So yeah, as we mentioned earlier, that there were like some modularization in Spring Boot. So we have now new modules. That's how like the OpenTelemetry starter, the Zipkin starter is there. And look into the migration guide of Spring Boot 4, because that will contain all of these new modules. Not just these are included, but basically everything. Every single technology that Spring Boot supports, now it has a new module and starter as well. We added like a few Spring AI enhancements. Thanks for Thomas as well. So now Spring AI is more observable, and we are planning to continue this. Also, there are improvements for SSL info and health check for SSL. I'm not sure if you're familiar with that concept, but if you are using the info endpoint and if you are also using TLS, you need to enable this feature, and it will tell you what are the TLS certificates that your application is using, whether that's a server certificate or a client certificate. It will tell you the issuer, the subject, also the validity dates, so you will see when something will expire. It also can warn you if something will expire soon. So you can basically set a threshold that, hey, give me like a warning if my TLS cert will expire in a week, because that's what the headroom I need to rotate the certificate. Also, there were some changes in SSL bundle metrics, which is like metrics support for this SSL info thing, which can tell you that, hey, this many certificates will expire, I don't know, within a week. And also there were some enhancements for process info. We added a few fields so that now your application can tell you what it thinks the current time is, whether that's correct or not. And also like when the application was started, and so on. You can look into the process info contributor in the docs. It is very, very useful in production.
All right, and with that, does anyone have any questions? We have some time for questions. Remember, the code is available online if you want to check it out, run it for yourself, play around with that. Micrometer has a Slack if you want to ask questions later, but since you're here now, if you have any questions, we'd love to take them.
We also have stickers, Spring and Micrometer stickers in exchange for questions.
Stickers, and if you're doing the trading card game, come see us after the talk and we can give you trading cards.
Oh yeah, this is something that you can put like next to your desk so that you can see how I look like if you don't upgrade.
Remind you to always be on the latest Spring Boot version. Questions? Anyone?
Mm-hmm.
I would say that...
Can you repeat the question first?
Yes, so the question was, you've been using Brave for a long time, and you looked previously into switching to OpenTelemetry for the tracer implementation, but it was missing some features that Brave had. What does that look like today? I guess my question would be specifically what features were missing that you were looking for. But the general answer is that OpenTelemetry is under active development, whereas Brave is more in a maintenance mode. And so, you know, Brave is very stable and battle-tested in production, but OpenTelemetry is going to continue to add new features. And so I would imagine in general it has caught up in feature parity and has some features that Brave probably doesn't have.
I guess one feature that like Brave had, you might use it is like the span continuation thing, like when it can continue a span without like creating a new one. Do you remember what was the name of it?
You mean when the client and server span on HTTP where it's combining them?
Yes. So that, as far as I know, OpenTelemetry cannot do this combination of spans. Brave can. Other than that, yeah, they are like usually pair in general for like basic features.
Yeah, but if we could talk after if you have specific features that you're interested in. Yeah, I mean, again, For specific things, there will, of course, be a concrete answer, but in general, I would just say that OpenTelemetry is under active development, so if something is missing, it's more likely that it will be there eventually if it's not already.
But with the observation API, it doesn't really matter. Like if you have support for something like a certain library that uses the observation API, then it doesn't really matter like what tracing library will be used under the hood. You will get instrumentation out of the box for that component through it.
Yeah, this is sort of the point of the facade of using Micrometer, both the observation API and Micrometer tracing, is the idea is if you're instrumenting it with that, it doesn't matter what the underlying tracer is so much because you can swap them out and you should have equivalent functionality. One last question, anyone? All right, well, then thank you for coming to our talk. If you have any questions later, come see us. If you want stickers, cards, let us know. Thank you.